Welcome trio. Today we're going to go over solving quadratic equations by completing the square. Completing the square is useful when you can't factor the equation, and if it's not factorable you only have two options: completing the square or using the quadratic formula. Sometimes completing the square is quicker. So let's do it with this example. So the first thing you need to do is move your c to the other side and make sure your leading coefficient is just 1. So let's do that. X squared plus 5/2 x equals negative 7/2. If I move it over, it becomes negative. Now, to complete the square, what we need to do is say c equals bracket 1/2 b squared. So now if I plug that in, c equals 1/2, b is 5/2, and then square it. That means 5/4 squared. If I square 5/4, that gives me 25/8. Nope, 25/16. 4 times 4 is 16. So now, this is the new c I'm going to place here. So I get x squared plus 5/2 x plus 25/16. I add it to the equation. If I'm adding something to the equation, I have to add it on both sides. So then that gives me negative 7/2 plus 25/16. I add it here, I add it there. The reason I add it here is so I can have a perfect square trinomial. Now this becomes x plus the quantity that was squared, 5/4 squared. This whole side becomes this. Equals, I need a common denominator. I need to multiply 2 by 8 to get 16, so I need to multiply the top by 8. Negative 7 times 8 is negative 56/16 plus 25/16. If I combine that, that gives me negative 31/16. Now I take the square root of both sides. If I take the square root of this side, I always have to put plus minus negative 31/16. So now this becomes x plus 5/4 equals plus minus. If I take the square root of a negative number, that means I get an imaginary answer or a complex answer. So this is the imaginary part of our complex answer we're about to obtain. Negative becomes the I, root 31. Square root of 16 is just 4. Now I move this over, and when you have a complex answer, it's always the real part first. So when I move this over, it becomes negative 5/4. Then plus or minus the imaginary part, I root 31 all over 4. This is our answer, and I'll be back with another example. Okay, we're back with a new example. We're still solving by completing the square. But remember I said when you're completing the square, the leading coefficient should be 1. In this case, it's not. So we need to divide by that leading coefficient first. So if I divide everything by that, so I divide everything by 4, that gives me x squared minus 3/4 x equals negative 5/4. Now, for completing the square, we can find c. C equals 1/2 b squared. So c is going to equal 1/2 times negative 3/4 squared. If I multiply these two together, that gives me negative 3/8. And if I square that, that's going to give me 9/64. Remember, squaring a negative becomes a positive, so we get 9/64. We're going to add that to both sides. X squared minus 3/4 x plus 9/64 equals negative 5/4 plus 9/64. Whatever you add to one side, you have to add it to the other side. The reason we added it to this side was so that we could have a perfect square trinomial. This becomes x minus 3/8 squared equals, well, now I have to figure out what I need to multiply here to get a common denominator. Well, that's just going to be by 16. 16 gives us 64. Now, 16 times 5, that sounds like 80. Negative. Let's see, that's, yes, that's correct, 80. Negative 80. So we combine those two over here, we get x minus 3/8 equals negative 71 over 64. Take the square root, x minus 3/8 squared equals plus minus the square root of negative 71 over 64. Again, we're taking the square root of a negative. That means we're going to have an imaginary answer there. So we get x minus 3/8 equals plus minus I square root 71. The square root of 64 is 8. Now we have to move over this to solve for x. When you move it over, you always put it in front of the plus minus because it's the real part of our complex answer. A complex solution has a real part and an imaginary part. X equals 3/8 plus minus I square root 71 all over 8. That's our solution. I'll come back with one more example. Thank you. Welcome back. Here's our final example, and let's get started. Remember, when you're completing the square, the leading coefficient should be 1. In this case, it isn't. So first thing we have to do is divide by that leading coefficient to make it 1. So 3x squared over 3 plus 2x over 3 plus 7 over 3 equals 0 over 3, or x squared plus 2/3 x plus 7/3 equals 0. Now remember, when we want to complete the square, we need to move this c term over, the constant term over, so we can find a new constant term by completing the square. So we're going to move that over and say x squared plus 2/3 x equals negative 7/3. Finding c, our new constant, the formula is 1/2 b squared. So c equals 1/2 times our 2/3, and then square that. 1/2 times 2/3 is just 1/3. And we want to square that, that gives us 1/9. We're going to add the 1/9 to our equation so it can be our new constant. X squared plus 2/3 x plus 1/9 equals negative 7/3 plus 1/9. Whatever you add to one side, you have to add to the other. The reason we added this is so we can have a perfect square trinomial. Now we can factor that as x plus 1/3 quantity squared equals, we got to combine this, so we need like denominators. Multiply this by 3, we get negative 21 over 9 plus 1 over 9. We get x minus 1/3 squared equals negative 20 over 9. Take the square root of both sides. Get the square root, x minus 1/3 squared equals plus minus square root negative 20 over 9. 20 has a perfect square in it, which is 4 times 5, so we can pull out the 4, but it's negative 20, so we need to take out an I. We get x minus 1/3 equals plus minus I, and because we're going to take out, I'll rewrite it here as 4 times 5, square root of 9 is 3. We can simplify this as x equals x minus 1/3 equals plus minus 2i root 5 all over 3. So square root of 20, 4 times 5, take out the 4, square root of 4 is 2. The negative became an I, so that's 2i. Now we just have to move this over. X equals 1/3 plus minus 2i square root 5 all over 3. We have our real part, we have our imaginary part. This is called a complex answer. And we are done. Go Trio!